Good day, my students. Welcome to my class. I am your teacher, Juni Castigon. So our first lesson for this school year is about generating pattern. As you can see here, there's a question: what will come next in this pattern? So we have here a triangle, two green triangles, then we have upside down yellow triangle, and so on. So at this lesson, we'll be able to generate pattern because the objectives for today is generating patterns. Okay, I want you to look around where you are now and find something that has a pattern and answer these questions. How are the designs from around the world formed? Second question, how many patterns form? The third question, where can we see patterns? And the fourth question, and how will you complete a shape or a number pattern? These questions will be answered right after the discussion of this topic. Today we will be discussing about generating patterns. So our objective for today is very simple: to generate pattern. So before discussing what pattern, the different patterns, let's identify first, or let's define first what a pattern is. A pattern is an arrangement that we usually found in a comparable object. Example, let us consider the wheels in a vehicle all over the world. When we say wheels, it's around, right? So the pattern is very simple and it's very common sense. However, let's take for instance a t-shirt. It has 4 holes. One for your torso, second is for your neck, and the other 2 holes are for your arms. So what is the relationship between this a pattern in mathematics? In mathematics, we have number patterns. Number patterns is a set of number that follows a certain pattern. And the one example of the common example of number pattern is the counting numbers. Like for example, from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And every sequence, or in every members of the sequence, it follows a pattern. So that is why the rule is n. So in every term of the sequence, like 1, 2, 3, 4, 5, and so on. So in every term of the sequence, there is a certain pattern, or there is a certain rule. So that is generally n. N means the first term, the second term, the third term, the fourth term, and so on. So in mathematics, we call this one as sequence. A sequence is a number pattern that follows a certain pattern. For example, 3, 5, 7, 9, and so on. This is a sequence of number. Now, let's try to identify the pattern of the sequence. From 3, why it became 5? From 5, why it became 7? From 7, why it became 9? Let's try to check what's the pattern. So maybe we add 2 here. So we add 2 from 3 to get 5. We also add 2 from 5 to get 7. We also add 2 from 7 to get 9. So therefore, So the pattern here is we keep on adding 2 to get the next number. So in this sequence, we keep on adding 2 to get the next term. Let's take another example. 2, 4, 8, 16. Let's try to identify the pattern of this sequence. What did we do to 2 that becomes 4? What did we do to 4 that becomes 8? What did we do to 8 that becomes 16? Maybe did you add 2 to become 4 here? We will add 4 to become 8. And here we will add 8 to become 16. Now this pattern is, let me say, difficult, because if we keep on adding 16 here the next term to get the next term, then the pattern is increasing. I mean, it's difficult. So we can in getting the pattern, it's not about addition only. We can also use a combination of subtraction, multiplication, or division, or any other techniques. So in here, let's find another pattern. Let's try multiplication. What did we multiply to 2 that becomes 4? So that's times 2. What number do we multiply to 4 that becomes 8? Still 2. What will you multiply to 8 that becomes 16? Still 2. So I see pattern here. That means if we keep on multiplying 2 to get the next term. So in mathematics, there are many different types of sequences, like arithmetic sequence, geometric sequence, harmonic sequence, and Fibonacci sequence. There are also books that consider another sequence like square sequence, triangle sequence. There are a kind of sequence here. This is what we call the infinite sequence. Infinite. When we say infinite sequence, it continues on because of these 3 dots. These 3 dots is called ellipses. That means if the sequence contains 3 dots or ellipses, that means if it's infinite. While this second sequence is finite sequence, there is no ellipsis that becomes finite. That means it ends with 16. There are only 4 terms here. It ended here. So that make this sequence a finite sequence. What you have learned by completing the following statements. A sequence is a number pattern in which it uses a certain rule. It could be addition, subtraction, multiplication, or division, or any other techniques. And a sequence could be in a finite or finite when it ends. It has no ellipsis symbol. And when can we say that it is also infinite? It is infinite. It is infinite when it has ellipsis symbol. And these 3 dots are the ellipsis symbol. Okay, this time let's try generating patterns. Let's start with number 1. Start with 288 and use the rule divide by 2. Here, the first term is 288. Again, the number in each sequence are called terms. So the first term is 288. Since the rule is divide by 2, so we will divide 288 by 2, and that is equal to 144. Next, 144 divided by 2, that is 72. Next, 72 divided by 2, that is 36. 36 divided by 2, that is 18. 18 divided by 2, that is 9, and so on and so forth. We keep on dividing 2. Okay? So this sequence is an infinite sequence because of the ellipses. Okay, let's try number 2. Start with 2 and use the rule, add 3, then multiply by 2. So the first term here is 2. Since the rule is we will add 3, then multiply by 2. So 2 plus 3, that is 5, times 2, that is 10. Next, 10 plus 3, that is 13, times 2, that is 26. 26 plus 3, that is 29, times 2, that is 58. 58 plus 3, that is 61, times 2, that is 122. 122 plus 3, that is 125, times 2, that is 250. 250 plus 3, that is 253, times 2, that is 506, and so on. Okay, let's try number 3. We have here the sequence 15, 19, 23, blank, 31, 35, blank, blank, 47. Let's identify the rule for this sequence. What do you think is the rule for this sequence? So we have here from 15, it became 19. From 19, it became 23. So in here, we add 4, right? So 15 plus 4, that's 19. 19 plus 4, that's 23. So that means in here, 31 plus 35. 31 plus 4, that's 35. So the rule for this sequence is plus 4. So by continuing the pattern, so 23 plus 4, that is 27. 35 plus 4, that is 39. And 39 plus 4, that is 43. So far, so good. So how about trying number 4? In number 4, we have here 58, 52, 46, 40, blank, blank, 22, 16, blank, blank, a blank 4, negative 2, blank, negative 40, negative 20, and so on. So let's identify the rule for this sequence. What do you think is the rule? So from 58 becomes 52, from 52 it became 46, from 46 it became 40. So what happened? So the rule is we subtract 6 in every term. So 58 minus 6, that's 52. 52 minus 6, that's 46. 46 minus 6, that's 40. 40 minus 6, that's 34. 34 minus 6, that's 28. 16 minus 6, that's 10. Negative 2 minus 6, that's negative 8. So, negative 40, negative 20, and so on. Okay, let's try the last number. Number 5. The rule, what is the rule of for this sequence? 2, 16, 14, 30, blank, blank, 2, 5, 4, blank. Now, let's try to find out the pattern. So when we use addition, does it work? 2 plus 4, that's 6. 6 plus 8. Okay, doesn't work. Let's try to find another pattern. Let's say multiplication. When we multiply 2 by 3, that becomes 6. 6 times 3, that's 18. It's not 14. So maybe in this sequence, there are two operations. So maybe like, let's try to add 1 and multiply it by 2. 2 plus 1, that's 3, times 2, that's 6. Correct. Another. 6 plus 1, that's 7, times 2, that's 14. 14 plus 1 times equals 15, times 2, that's 30. So the pattern works for the four terms here. So therefore, so the rule for this sequence is plus 1, then times 2. So let's continue the pattern. 30 plus 1, that's 31, times 2, it's 62. 62 plus 1, 63, times 2, that's 126. 254 plus 1, that's 255, times 2, that's 510, and so on and so forth. Answer the activity sheet number 1 by yourself. I want you to go to your Google Classroom and answer the activity. Okay, that's all for today, and thank you so much for listening, and I hope you had a great time. See you next week. Bye.